All right, so now we are going to be talking about Chapter 3, displaying and describing categorical data. So the first rule of data analysis is, hey, make a picture. And the second rule is make a picture. And the third rule of data analysis is make a picture. And there are a lot of ways to make pictures, and we will be learning each of those ways in the next few days of notes. But making a picture is very important. Lots of different ways you can make pictures of data for different types of data, and we'll practice those. A distribution will be the most used word in statistics throughout the entire year. And a distribution displays the possible values of a variable and how often it takes them. It's basically your group of numbers. A distribution is a group of numbers. So depending on the type of data and what you are looking for, there are a number of ways to organize and display the distribution. The numbers, that's all a distribution is. It's a group of numbers. So when a variable is categorical, the first step is usually construct a frequency table. How often, frequency means how often did some of the answers occur. So frequency means how often did the values occur. So, which displays the possible categories and the number of observations in each category. That's what a frequency table is. So let's just say I took a survey of a class to see what type of car they drove. You either drive an American car, an Asian car, or a European car, most likely. So I just did a survey. I just said, stand up if you drive an American car, and I counted the people who drove an American car. Let's say there's 5. And how many people drove an Asian car? Well, 2 did. How many drove a European car? Well, 3 did. So I had a total of 10 people driving cars in my class, very small class. So 5, 2, and 3. All right, so that is a frequency table, the number. And a lot of times what you might do, you're probably not going to have people stand up. You're probably going to have your information that you've collected. So you might have tally marks. You might be looking at like little pieces of paper that somebody wrote there. I drive an Asian car, okay? So and then you set that aside and you put a tally mark for the Asian car. And then you look at the next one. Oh, and it's an American car. And then you tally up what's underneath each of them using little marks like that. Then you write the numbers for the frequency table and add them up. All right, now, frequency is how often. The relative frequency is simply changing this into a percent for a particular category, is the fraction or proportion or percent of the time that the category appears in the data set, okay? Relative frequency, when not fraction, proportion, percent, they're all the same thing, okay? I can write the fraction 1/2, okay? The proportion 1/2, but I could write it as 50 over 100 and it would still be a proportion, and the percent is 50%. You can take a number and write it as a fraction, proportion, or percent. So frequency can be written in any of these ways, and most of the time we write it as a percent. Okay, a percent table, a relative frequency table. So now we take our raw data, our raw frequencies, how many of each, and we change them into percents, which is very nice to know. I like to know this when I go over tests. So when you take a test, I will make a frequency table for the tests. I will tally up the number of A's, B's, C's, D's, and F's. And I will write it for all the classes, and then I'll say, well, I had 15 A's and 10 B's and 8 C's and 6 D's and 2 F's. Okay, and I add them all up, so that's 15, 25, that's 31 students, and so I end up with 31 total. Now, I want to find the percent. What percent of kids got an A? That's important to me. I want a bigger majority, a bigger percent of my students to have A's, B's, and C's than D's and F's. So now, how do we find the percent? Well, all you're going to do is set up proportions. To go from this frequency table to a percent, you're going to say, well, 5 out of 10 is equal to how many out of 100? You take the number of American cars divided by the total, and really it's as simple as taking 5 divided by 10 and then multiplying by 100. Okay, take your value over the total times by 100. So that would be 50% of the people drove American cars, and that would be 20% drove Asian, and 30% drove European, and the total in the relative frequency table should always add up to 100%, which is the same as all the people. Okay, little note tells you the same thing. There are several ways to display categorical data. Okay, so today all we're talking about categorical data. So first of all, a bar chart, you could make a bar chart and a relative frequency bar chart. So we could take our same data that we just had, and we could make just a regular bar chart. A regular bar chart. Now, bar charts have bars that are separated because there's no flow of these. We could have the bars in any order, and it would be the same graph. So I could, I don't have to do American, Asian, European. I could put European first, and American here, and Asian here. So there are 3 separate bars, but the bottom is where the categories are. So our categories go along the bottom. We want to label them: American, Asian, and European. Okay, so we want to label them somehow. And then we are up here on the x-axis. This is our frequency. How many people had American cars? Now, yes, there were 10 people in the class, but I don't need to go all the way up to 10. Because I didn't have 10 in any one category. So I look at what's the highest number. I need to go up to at least 5 in my bar chart. And I just make a bar, a freestanding bar for each value. I don't have to color it in. I can if I really want to. And then the Asian cars were 20%, so I'm going to go up to 2. I realize that that's a pretty big jump there. Sorry, it's not perfect. And then European would be a little bit higher, up to the 3. So each of these corresponds up to the height of that. Okay, now a relative frequency bar chart is the same thing, only instead of having frequency or the numbers here, so 1, 2, 3, 4, 5, that's what you have this labeled. Over here on the vertical column, the vertical axis, you are going to have the percents, the relative frequency. Relative frequency means in relation to the whole, out of the whole, percent, okay, what fraction, okay, so we have the relative frequency here. So, okay, so now I'm just going to need to put these numbers on the vertical axis. If you've got a frequency table, it's easy to make a bar chart. If you have a relative frequency table where you've changed them to the percents, it's very easy to make this kind of bar chart. You have the same categories on the bottom, and then the only difference is you need to go up to 50%, 10, 20, 30, 40, 50%. These represent percents. Okay, these represent your percents. And now you're just going to say, well, the Americans go up to 50%, Asians go up to 20%, Europeans go up to 30%. Again, they're freestanding bars. They should be the same width. They should be the same distance apart. I'm a little off there, but this one was better. Okay, now notice, aren't these pretty much the same graph? They're identical. The only difference is the way you labeled the vertical axis. The thing that's going to make this difficult is you're going to make the phrase relative frequency bar chart seem like it's a very challenging thing. It's not. Frequency means how many. Relative frequency means percent out of the total. Change those how manys into the percent out of the total. All right, we're just about done here with the notes. We've got the top of the next page to go through. Now, when you're making bar charts, bar chart tips. Okay, these are tips for your bar charts. The horizontal axis should include the variable and the possible categories. The bar should have some space between them to indicate they are freestanding and can be arranged in any order. The vertical axis can be frequency, just numbers, or relative frequency, percent, and should include a numeric scale starting at 0. Relative frequency bar charts make it easier to compare multiple distributions, especially when the sample sizes are different. Now, we would like to know what is wrong with the following graph. I'm going to quickly go over this because the bell just rang. I'm going to have people coming in here. So, what's wrong with this? If you notice, DirecTV stomps the competition, and it certainly would look like it because its bar is about twice as wide as these other two. So it certainly looks like it's better just because of the size of that bar. Very misleading. Pie charts are useful. We are not going to deal with these. Okay? But in a pie chart, you want to make sure that the categories are different enough. Okay? You don't want all of these to be, all the parts of the pie to be about the same size. And then if you wanted to compare things, then you can take a bar chart for males and females and write them next to each other. That's a comparative bar chart. So you've got a few pages to read, and it looks like more problems, but they're a little easier.